Okay, class, where we are now, we've talked about the central nervous system, brain and spinal cord. So now we're looking at the peripheral nervous system. So let's investigate that. All right. All neural structures outside the brain and really outside the spinal cord, all neural structures outside the brain, and I'm going to add to that, and outside the spinal cord, would be the peripheral nervous system. Sensory receptors, peripheral nerves, and associated ganglia, motor endings, things of this nature there. Okay? Now, let's just go back to our definitions. A nucleus, let's do this. A nucleus is a group of cell bodies in the CNS. Okay. A ganglia, or ganglion, is a group of cell bodies IES, come on, Mike, in the PNS, peripheral nervous system. A tract is a group of axons in the CNS. We talked about that. And a nerve is a group of axons in the PNS. So that's your terms now again. What's that again? That's your terms. That's your terms. So right here, when they say neural structure outside the brain, and I said outside the spinal cord, peripheral nerves and associated ganglia. Okay? Ganglia. Ganglion is singular. And motor endings. Okay? All right. So we go further. All right. When we look at the peripheral nervous system, we can break it into the sensory. We talked about that. Senses go in, afferent, to the spinal cord. Remember that? Sensory goes in to the spinal cord. When we had the spinal cord, let's go back up here. I'm hoping these videos are helping you. I've spent a lot of time doing them. Let's see, where's that spinal cord there? Okay. So sensory goes in through the back. Remember, sensory came in through the back. Sensory came in through the back, and motor went out through the front. Sensory came in through the back. All right. All right, because here's the nerve starting there. All right, the sensory afferent goes in through the back. Motor comes out through the front. Motor can be somatic motor. Somatic motor, remember, goes to what? Somatic motor goes to skeletal muscles. Somatic motor comes out through the front. Autonomic motor, we're going to talk on a chapter with the autonomic nervous system, also comes out through the front. See, this is visceral motor, which is autonomic, and that's somatic. The first neuron cell body for somatic motor is right here, and the one here for visceral autonomic, and it comes out. Now, we're going to talk on this. So I'm not going to say a lot about the autonomic nervous system because there's going to be a chapter on that we're going to do. Okay? All right. But peripheral nervous system, sensory, motor can be divided into this. Actually, the sensory can also. They just didn't put it in here. But if you go back to my earlier one, sensory can be divided into somatic sensory, and remember that took care of the body wall, like the skin and so forth, a scratch. And then autonomic sensory, or visceral sensory, took care of, like if your intestines hurt or your bladder. So they just didn't complete that. I didn't draw this one. This textbook did this. But sensory itself can be divided into autonomic and somatic, and we've talked about that. Okay, let's go a little further. Sensory receptors respond to changes in the environment. Activation results in a graded potential, not an action potential, a graded potential. The more you push the more pressure you push, the more intensity I feel. The more, it's not all or none. It's not like I don't feel nothing or I feel max. So in other words, sensory receptors do a graded potential. Sensation, awareness of the stimuli, and what is it? Awareness. Remember we talked about association areas in the brain? Association areas. You touch me. Now what did touch me? You touch me was the primary somatosensory cortex. What it was involves various association areas in the brain that associate what you know. Now those association areas, you had to program them. What does that mean? How would you know what the heck a pen is, a stick pen is, unless you've experienced a stick pen? So the association area ain't by magic, ain't nothing by magic. You'd have had to have an experience and seen one and understood one for the association to even associate. Let's just use some common sense here. Okay? So we go further. Classification of receptors based on the stimulation type. See, there are different modalities. Is it touch? Is it pressure? Is it pain? Is it temperature? Where are they located? Are they located outside in the skin? Or are they located inside in the visceral organs? How complex are these? Some are very complex as to how they receive. Like, for example, your in the retina, your photoreceptors are very complex. Okay? So we have mechanoreceptors, touch, pressure, thermo, sensitive to changes in temperature, photo, in your eyes. Chemo respond to chemicals like smell, taste, things of this nature. These are chemical signals being interpreted. Nocio means pain, ladies and gentlemen. Nocio means pain, nocioreceptors. Okay? Exteroreceptors, just like I was talking about in the skin or the tongue, more in the surface. More in the surface. Internal visceral, like your blood vessels or the bladder, things of this nature. Okay? Proprio, position in space. How do you know how to make the next step unless you know what position your legs are in before you make the next step or you'd fall? Complex receptors involve those special senses, hearing, sight, things of this nature there. Simple receptors are just touch receptors, very simple. Uncapsulated free endings. Let's go down here. Let's go down here. See where we are. Okay, we'll journey down a little bit here. Okay, so we have different kinds. We have uncapsulated. Let me see if I can find something. Okay. So we have some just that are just non-encapsulated endings. They just, and particularly in the skin area there. Simple receptors, tactile, uncapsulated. Let's go a little further here, see what we got. Thermoreceptors. You have cold receptors in the superficial dermis and heat in the deeper dermis. Cold in the superficial dermis, heat in the deeper dermis. See, heat can travel further down. Heat can travel further down. Okay. Nocio respond to pinching, chemicals from damaged tissue, various things. These are pain receptors. Like acid on the skin. Temperature is outside the range of the thermoreceptors. What does that mean? That means if you put something cold on your skin, certainly the cold receptors will respond. But once it gets too far, then pain receptors will come in. Now I'm going to throw another little thing out there. Your photoreceptors in the eye, in the retina, your photoreceptors in the retina respond to light, right? They respond to light in the retina, your photoreceptors. But if you close your eye and push on the eyeball, close your eye and push on the eyeball hard enough, you're going to see flashes of light. Why? Because one modality can extend into another modality if you take it to the extreme. Let me say that to you again. One modality one sense modality, touch, pressure, whatever, can go to another one if you take it to the extreme. Capsaicin is a substance you can put on the skin. Okay. So again, like I say, these things can do this here. And even capsaicin, which again, like I say, is something that really is something like in chili peppers and so forth like that, you know, that hot stuff on the mucous membrane. It could really give you a good sensation, hot sensation. Light touch, tact Merkel's disc, hair follicle receptors. Let's talk on that. So right here, okay, right here is a Merkel's disc. Now let me tell you, go back to the skin. Go back to the skin. Okay, remember we had hairy skin and non-hairy skin, which the non-hairy skin was called glabra skin. It was the palms and soles. All right, so light touch on skin that does not have hair, like the palms and soles, you would push down and you would activate this Merkel's disc. Now the Merkel's disc is in the bottom of the epidermis. And then here would be a Merkel cell. So in other words, that Merkel's disc, which would be then would activate this Merkel cell, which is in the dermis. The Merkel's disc would deliver a transmitter substance that would activate for light touch. But if you're in skin that has hair, let me find that. If you're in skin that has hair, then see, just bending the hair would activate these spiral nerve endings. So you'd already know a mosquito stepped on you. Okay. Let's go a little further. All right, we just looked at that. Okay, so now we're looking at all the encapsulated dendritic endings. Let's see if we can find something here. All right, so what do we have? Okay, the Meissner's corpuscle, which is more of a pressure deal. Discriminative pressure, discriminative touch. Okay, it can do pressure, it can do touch. It can do pressure, it can do touch. See, it's up in this upper area. Okay. More discriminative touch than pressure, but it can do pressure too. Now here's for deep pressure. See, that's more of a light pressure. The Pacinian Corpuscle. See how deep it is? You have to put, and that's an encapsulated. You have to push hard down to get to that boy. That's an encapsulated. Ruffini endings, these are here. Muscle spindles, which are these right here. See, muscle spindles, go back to the muscle chapter. They kept tonus on the muscle. Go back. Then you had the Golgi tendon organs. Remember I said that when the muscle tightens, it puts a lot of pressure on the tendon. So the Golgi tendon organ works opposite to the muscle spindle. But both of these are mechano, because that's mechano, muscle, and this mechano. And then you have stretch receptors in your joints to kind of determine what position. These would be stretch positions in the joints. Okay, let's go a little further. So again, here's a picture that you can glance at. These Meissners, dermal papillae of hairless skin, right there. Okay, Meissner's corpuscles, particularly in the nipples and so forth. So see right here with these Meissners again, look at them right there. So what do you have on that hairless skin? You got the Meissners and the Merkels to kind of help. Okay. From sensation to perception, we're going to stop right here and start a new one.